All right, students, so we're going to do a quick video on rate of change and specifically with linear functions. Looks like this fish is changing bowls. All right, here we go. So we first looked at recursive form, which was p sub n equals p sub n minus 1 plus d. And so this was just, one period or whatever we're looking at is the previous one plus whatever that rate of change was, the slope. And so then we also looked at the general form, which was p sub n equals p sub 0, and p sub 0 was the starting point, or our intercept, like if we were looking at it graphically, plus the slope times n. And we talked about slope, where slope is really just the rate of change. It's the change in the y over the change in the x, or we could think about our independent variable and our dependent variable. We could think about our input and output, and then we just describe that as y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So all this is it's the change in y with respect to the change in x. So how much, if x changes, does it impact our y? So let's take a look at an example. So for example, in 1995, the first coyote was spotted in Central Park. In 2015, approximately, there were about 41 coyotes in New York City. When will there be 100 coyotes in New York City? So this is just an example problem, and in order to solve this, we would actually need to know what the rate of change is. So how much have coyotes changed over time? So our independent variable is time. Time is just going to move on no matter what. And then coyotes are dependent on time, right? So let's take a look. So our change in y, which is our change in coyotes, what is our change in coyotes with respect to time? How many coyotes have increased over time? So in this case, it was 41 that we have in 2015 minus the 1 we had in 1995 over 2015 minus 1995. So it was 40 coyotes in 20 years. And so we looked at unit rates a while ago, and this is just 2 coyotes per year, right? And that is just representative of a slope. So we could actually now solve this problem using either the recursive form or the general form or explicit form. So we can just figure that out. So let's do that. So I'm going to use the general form just because it's a little easier for me. Like otherwise we would have to just figure this out, over time. Like we just have to plug in and chug all of the years until we figure out the correct answer. So the general form is a little easier to solve a problem like this. So I just said 100 equals 41 plus 2n, and then I just solved for n. And n is about 30 years. It's 29.5 years. So, and remember, so that's going to be year 2045, right? Because we're going to add 30 years to the 2015 that we started from. So that's the year that we're going to have about 100 coyotes. So let's think about that problem a little more and take a look at this graph. So first we're going to graph time on our x-axis down here on the horizontal axis, and then we're going to graph coyotes. That's actually not a coyote, that's my dog. All right, there's a coyote. And then so I'm just going to I just picked this scale of 10, 20, 30, 40 up this y-axis. Now, if I graph that, it's going to look like this. That looks like a tremendously steep slope. Now, that can be a little deceptive, right? Because it looks like coyotes are growing really fast. But, and this is what we talked a little bit about scale, so just be really careful when you look at graphs, because you can choose the scale you want on the x and y axis to make the graph look differently. So just for example, if I change my scale like that, then all of a sudden the graph doesn't look as steep. So that's a deceptive thing because nothing has changed in my data. It's just how I'm representing it. So for example, I have my change in time right here and my change in coyotes right here. So the change in coyotes have increased 40 over 20 years. And so that's just what we talked about. Our slope of this line is going to be 2, not 40. Let me fix that. Two. And that is just going to be D. So I hope this helps, and please let me know if you have any questions. Thanks.